right, we are going to look at rational numbers. So a rational number is a number that can be written as a over b, where a and b are integers and b doesn't equal 0. Now that might all sound confusing in that big definition, but one thing we can look at is if we see within this word rational number the word ratio, all it means is that a rational number can be written as the ratio of two integers. Okay, and remember, integers are whole numbers that are either positive or negative. So let's look at some examples of rational numbers. Okay, I've written, the first one is 5 over 1, because we know that 5 over 1 is simply 5. So in other words, all whole numbers are rational numbers because a whole number could always be written as that number over 1. So any whole number and any integer, positive or negative, is a rational number. But what we also can add in are fractions and decimals that are positive and negative. So for example, we have 3 over 2. Okay, 3 over 2 could also be written as 1.5 or 1.5. But because it can be written in this form, 3 over 2, where a, that's here, is an integer, and b is an integer, then this is a rational number. Okay, another example here is negative 4/3. Okay, again, negative 4 is an integer and 3 is an integer, so this would be a rational number. Okay, I've also included some decimals like 2.4. Okay, so for example, right, you could write 2.4 as 24 over 10, so that's a rational number. You can write negative 3.8, you could write as negative 38 over 10. So again, that's also a rational number. Okay, and then I've also written 0.3 with a bar. In other words, right, this would be 0.3 repeating forever. Okay, because we know that actually represents the fraction 1/3. So, the easiest way to see this is that any fraction with whole numbers, any whole number, any integer, and any decimal that's either terminating, like 2.4 and 3.8, or repeating, like 0.3333333, those are all rational numbers. Okay? Now, the only time something is not a rational number is if it's what we call an irrational number. And those are numbers like pi, right? You may have noticed the pi chart, if you will, on our wall in our classroom. And it just has a long series of decimals that never repeat, right? There's no pattern to it. It's just a number, and that decimal goes on forever. So that would be an example of a decimal that is not terminating. It doesn't end definitively, or it's not repeating. It doesn't have a pattern that it follows. So that would be an irrational number. But most numbers that we work with are actually rational numbers. So we could think about, right, you've got whole numbers. So whole numbers you've been working with your whole life, right? 0, 1, 2, and onward in the positive direction, right? Then we've recently started talking about integers, which just add the negative component to it. So integers are always whole numbers like negative 1, negative 2, negative 3, negative 4, and so on. And now we're just adding rational numbers. So rational numbers are positive and negative, but they include fractions and decimals and that sort of thing. So we're going to take a look at graphing some rational numbers and then also comparing and ordering them like we've done before. So let's look here. If I wanted to graph, for example, let's say negative 1.5. Okay, right? We can see negative 1.5. I've got negative 1 and negative 2, so halfway between that would be negative 1.5. And I could also graph its opposite if I wanted to, which would be positive 1.5. So here's negative 1.5, here's positive 1.5. Okay, now let's say we want to compare negative 3/4 and negative 1/2. In other words, which is greater and which is less than. So let's take a look. Negative 3/4, I can see here, right? I could break this up into fourths, and this here would represent negative 3/4, and this one would represent negative 1/2. So again, this is negative 3/4. This is negative 1/2. And I can see that negative 3/4 is farther to the left. So just like before, that means that negative 3/4 is less than negative 1/2. Now if we wanted to look at another one here, so in this one we're going to compare, actually we'll go ahead and order. So we're going to put in order from least to greatest the following three numbers. We've got negative 2.3, negative 1.5, and negative 2.0. So if we wanted to graph these 3 points, we can see here's negative 2.3, here's negative 1.5, and here's negative 2.0. So from least to greatest, again, farthest to the left is always going to be the least. So from least to greatest, we'd have negative 2.3, followed by negative 2.0, and finally negative 1.5.